Welcome to T1 Academy. In our last videos, we discussed about permutations and combinations. Today in this video, we are going to discuss an important concept, that is probability. Okay, in this probability, students, before going to this probability, everyone please have a glance on that combinations concept. Okay, please go and watch the combinations video, then you can easily understand these probability questions. Okay, so after watching that, it becomes easy if you watch this probability video, student. Why? Because we are going to use the applications of combinations in our probability. Okay, now when it comes to the probability, what is the basic idea of this probability? In general terms, if I want to tell what is meant by probability, means chance. Probability is nothing but chance. What is the chance of raining today? Or else, what is the chance of having, what we can say is, today is a Monday, and something like this, chance. Probability is nothing but chance in day-to-day life. If I want, see if it rains today or not, it may or may not be, right? Probability of raining depends on the previous predictions and all those things. So that is called as probability, where in the case of probability, we will tell each and every detail in a, what we can say is a data based manner. Okay, not randomly that whether it will rain or not, means the chances will be very rare if I want to say today. But what happens if I see the statistical data from the past some 20 years or 30 years based on today's date, then I can say that whether it will rain or not or something like that, we will see. So we will have some data, and on that we are going to work what is this probability. Okay, now probability means generally, probability means the desired outcomes by total number of outcomes. Desired outcomes by total number of outcomes. Desired outcomes by total number of outcomes. So now see here, we will have different cases in this probability, right? Coins case, dice case, playing cards, balls, and all these type of different cases we will have in this probability. Now see here, for example, in a bag or anything like this, in a bag there is only one ball that is red in color. Only one ball that is red in color. If I take out that ball, what is the probability of getting a red colored ball? Definitely 1, right? The probability will be 1. Why? Because the available ball for me here is only one ball which is red in color. So the maximum probability which I will get here is 1 only. Anyway, I am going to pick one ball, so that one ball will be obviously red in color. So the probability here will become 1. Now, similarly, I have a bag. In that I have two balls. One is red in color and the other one is blue in color. Right? Now I am picking one ball from this one. What is the probability of getting a red colored ball for me here? Will I say definitely that definitely a red color ball will come out? No. 50-50 chance, right? You will say 50-50 chance. 50-50 chance means what? The probability here becomes 1/2. What does it mean? That means my desired output is a red colored one, and the total number of chances, either it may be red colored ball or it may be blue colored ball. Because of that reason, I will write my probability as what? 1/2. Probability as what? 1/2. That means what I can say here is probability always lies between, for any event, it lies between 0 and 1. Probability will lie between 0 and 1. The maximum probability of any event will be 1. The maximum probability of any event will be 1. The minimum probability of any event will be 0. That means if that event doesn't happen at all, then my probability will become what? 0. So while solving the answers, make sure that your answer will be always in between 0 and 1. If it is beyond 1, then definitely you have done something wrong. And please cross check it and once again verify it and write the perfect answer there. Okay, that means probability lies always between 0 and 1. 0 and 1. Okay. And I told you that probability is nothing but the desired outcomes by total number of outcomes. Desired outcomes by total number of outcomes. Now, in this probability, students, we will have questions based on coins, questions based on dice, and questions based on what we can say playing cards, and questions based on balls, colored balls, and general questions. General questions based on the probability. That means there will be some standard questions where whether the things will happen or may not happen. Like that we will see the different. So now in this video we are going to discuss about the coins case. Coins case. Now what is this coins, sir? How we are going to see this coins case means, see here, when you toss a single coin, when you toss one coin, how many outputs will you get, students? What are the possible outputs for me? Either I will get head or I will get a tail, right? Only two chances for me. When I toss a single coin, I have two choices. One is head or the other one is tail. Only two chances we'll have. When I toss two coins, what are the possible outputs for me? Both head, tail, head, tail, or tail, right? So how many outcomes are there for me here? 4 outcomes are there. Now when I toss 3 coins, how many outputs I will have usually, tell me? Now in general, see, we are writing all this in a general manner. Later we will see a simple shortcut. We all know that one. When we toss 3 coins, what are the outputs? I will write it in the standard form: head, tail, tail, head, tail, head, tail, like this. So these are the possible outcomes for me when I toss 3 coins. How many outcomes are there for me here? 8. How many outcomes do I have here? 4. And here 2. If you observe carefully, for one coin, how many outputs do we have? 2. For one, we will have 2 outputs. For 2 coins, for the first coin we will have 2 outputs. For the second coin also we will have 2 outputs. When it is 3 coins, for first we will have 2, for second we will have 2, and for third we will have 2. Okay, so because of that reason, for n coins, we will have 2 to the power of n total outcomes. Okay, for one coin we will have total 2 to the power of n outcomes. That means if I toss 4 coins, what are the possible outcomes for me, students? When I toss 4 coins, I will have 2 to the power of 4, that is equal to 16. My total outcomes here will become how many? 16. If I have 5 coins, the total outcomes will become 2 to the power of 5, that is equal to what? 32. And so on, This is how we will find the total outcomes. When one coin is tossed, only 2 chances, head or tail. When 2 coins are tossed, we will have 4 chances each, head, tail, head, and so on. Head and tail. Okay, like this we will have different types of outputs for us when we toss 2, 3, 4, 5 and so on, different types of coins. Okay, sir, good. Now see here, students. Now we will see the general cases. Now when 4 coins are tossed, or else generally we will take a 3 coin case only. Why? Because a simple and easier one, right, for us. We will take that one only. When 2 coins are tossed, students, what are the possible outcomes for us? Just now we have seen head. I am writing this based on the, what we can say is a binary series we will have, right? Based on that we can take this one, head, tail. To write the all possible outcomes, I will use this technique here, so that now all the possible outcomes are written for me. Okay. Now, what is the probability of when 3 coins are tossed? What will be the probability of getting exactly 2 heads? What is the probability of getting exactly 2 heads here, students? Exactly 2 heads. I am telling that when 3 coins are tossed, what is the probability of getting exactly 2 heads? Where we have? I have 2 heads here. I have 2 heads here. Am I correct? Do you have any other place? No, that's it. I have 2 heads here, and here. So total how many are there? Required. Desired is how many? 3. By total outcomes are how many in number? 8. So the probability here will become what, students? 3 by 8. The probability here becomes what? 3 by 8. Okay, good, superb. Now similarly, what is the probability to have at least one tail? What is the probability which we will have? In general, at least one tail means I should have one tail in that one. Now in all this, except these three heads, in all this I will have at least one tail, right? So that means what I can write directly, 7 by 8, or what I can find it in another manner, 1 minus no tail case. That also it will be possible, right? At least one tail is 7 by 8, we all know it. So the reverse, the negation of it, how I can find by using the negation means 1 minus no tail at all. Now that means no tail means what does it mean? No tail means all are heads, right? All heads. That means what it becomes 1 minus, what is the probability to have all the three as heads? Only one time, right? So what it becomes? 1 by 8, which in turn gives us what? 7 by 8 only, which in turn gives us what? 7 by 8. So either you can find the things directly, and sometimes based on the requirement, we will find them indirectly also. Why? Because see here, if a event to happen and not to happen, if the sum is equal to event, this is the probability of an event A to happen, and this is the probability of an event A not to happen. If their sum is equal to 1, then what I can find? Probability of A is equal to 1 minus probability of the event A not to happen. We use the same logic here. Happen and not happen is equal to 1. Then the probability of to happen will become what? 1 minus probability of not happening that event. The same logic we are using here, and we are finding the answer for this one using the negation technique. Okay, good sir. Now the same thing, sir, if there are 2, 3 and we have written in this manner, but we have one more logic. Using the help of, we will take the help of our combinations. See here, exactly 2 heads, right? Total outputs are how many? We will get 3. In that I should have 2 heads. So that means what I can write this one? 3C2, right? Desired output is what for me here? 3C2. From 3 outputs we will get, right? When we toss 3 coins, out of those 3, 2 should be what? My heads. So 3C2. 3C2 is nothing but this is equal to what? 3C1. Please do watch the combinations video so that you can understand why I am writing 3C2 is equal to 3C1. So this is equal to what? 3. So my desired is 3, and total anyway by seeing the number of coins we can say that is 8. So what will be outcome here? 3 by 8. So we are going to use the methods of our combination here. To get the answers quickly. See, we can find it in the generalized manner or in the, what we can say, by using the combinations also. But what happens for us is, if we start using the combinations, definitely it will save us a lot of time. If not, each and every time you need to write all these things manually and then count them. Okay, but it will waste a lot of time, students. That is not a best idea. In worst case, if you are not able to solve with the formula or by using the concepts of combinations, then it is fine. If time permits, you can solve it at the end of the examination. But in general, we will not have that much time in any examination. So because of that reason, try to practice each and everything with the help of combinations only. That is the best practice. Now, we will see the questions. See here, a coin is tossed 4 times. The probability of getting exactly 3 heads is. Now see here, students, whether 4 coins are tossed at once or a single coin is tossed for 4 times, it will not make any difference. How, sir? See, when a single coin is tossed for 4 times, the outputs will be what is first, next and so on, like we are going to check like that. That means first time it will be head, next tail, head, and next another chance is what? First it may be tail, head, head. Like this we will have 4 outcomes. And similarly, when 4 coins are tossed simultaneously, on my first coin it may be head, tail, head, and on my second combination will be what? Something tail, head and head. So that means both concepts are same. When 4 coins are tossed simultaneously, what will happen? We will check what is the output on each and every one according to the order. That means first, second, third and fourth coins. When one coin is tossed for 4 times also, more or less there also we are doing the same thing. What is the first outcome, second outcome, third outcome, fourth outcome, like that. Anyway, both the things are same. No need to think too much about it. Whether we are throwing 4 coins simultaneously or only one coin at once, both are same. Both are same, there is no difference between them. Now, a coin is tossed 4 times, the probability of getting exactly 3 heads is, the probability of getting exactly 3 heads. See students, already I told you how we can find when I throw 4 coins or a coin for 4 times. What is the total number of outcomes? Same thing, that is 2 power 4, that is 16. This is the total number of outcomes for me. Now, what is the desired one for me? Desired, out of 4 coins, 3 should be heads for me. So, what you will write? 4C3. 4C3, out of 4, 3 should be heads. So, 4C3. So, what it becomes, students? 4. 4C3 is nothing but 4. So, therefore, probability will become what? Desired 4 by total number of outcomes 16. So, here my probability will become what? 1 by 4. Here the probability becomes 1 by 4. 1 by 4. Understood? So, by using this, if not, what happens here is, you need to write all the 16 outcomes. You need to write all the 16 outcomes and then solve it. It will take a lot of time. And sometimes you may get confused while writing all the 16 outcomes also. You may write the same thing for multiple times, or you may miss something, and to search what it is missing, it will waste a lot of time. Instead of that, better follow this method. Okay, right? Next one. A coin is tossed 10 times, the probability of getting exactly 6 heads is. Okay, now when a coin is tossed for 10 times, single coin was tossed for how many times? 10 times. So, what will be the total outcomes here for me? 2 to the power of 10. 2 to the power of 10. 2 to the power of 10, what it becomes? 1024. Right? 1024. 32, 64, 128, 64, 128, 256, 512, 1024. Yes, that's it. 1024 we will have. Next, what is the desired output for me here? Exactly 6 heads. I should get exactly 6 heads. That means what I will do? 10C6. Out of 10, 6 should be heads for me. 10C6. 10C6, what we will write for 10C6 students? 10C4. 10C6 is equal to 10C4. Why? Because 10 minus 6, it becomes what? 4. 10C4. What is 10C4? 10 into 9 into 8 into 7 by 1 into 2 into 3 into 4. 4 2s are 8, 3 3s are 3, 9. So, 10 3s are 30, 210. So, total outcomes are 1024 and desired outcomes are 210. Now, what will be the probability here for me? Probability will become 210 by 1024. 210 by 1024. Now, try to cancel it. In what table we can cancel it, students? In 2 table, 115, 105. In 2 table, 105. This will become what for us here? 512. So, the output will become what? That means the probability here becomes 105 by 512. 105 by 512. So, that means the probability to have exactly 6 heads is here how much? 105 by 512. 105 by 512. So, please observe carefully what is the desired one and how we need to find it. Next one. On tossing 6 coins together, what is the probability of getting at least 4 heads? At least 4 heads. Now, I am tossing how many coins here, students? I am tossing 6 coins. And how many output? What is the desired output for me? At least 4 heads. First of all, find out what is the total number of outcomes. 2 to the power of 6, right? Total number of outcomes here becomes what? 2 to the power of 6. Why? Because we are tossing 6 coins simultaneously. So, this will become what? 64. So, total number of outcomes will become what for me here? 64. Now, when it comes to the desired one, so at least 4 heads, right? So, what will be my output? 4 heads and 2 tails. 4 heads and 2 tails. Obviously, the other should be 2 tails. Or 5 heads and 1 tail, or 6 heads or 6 heads. Now, see here, students, no need to worry about these tails. Earlier also, see, if you want only exactly 4 heads means what you have done? 6C4. If you want exactly 6 heads means what you have written 10C6. Did you bother about the tails in that case? No, right? So here also the same thing, we will not bother about these tails. We will only check for the heads. So what is the probability of getting 4 heads, students, here? Out of 6 means 6C4. Or means what? Or. Already we discussed in combinations. We will take it as plus. 5 heads means 6C5 plus 6C6. All heads. All are heads. At least, right? So minimum to maximum. Minimum to maximum. So 6C4 is also equal to what? 6C2. 6C4 is also equal to 6C2. 6C5 is equal to what? 6C1. 66 will be equal to what? 1. 66 will be equal to what? 1. We already know. 62. 6 into 5 by 1 into 2. Plus 61 is what? 6 plus 1. 2 1s, 2 3s. 3 5s are 15. 15 plus 6 is 21, 22. 22 is the desired output for me. Now what will be my probability here? Desired outcomes by total number of outcomes, that is 64. So 2 11s, 2 32s. So what will be the probability here for me? 11 by 32. The probability here becomes what? 11 by 32. 11 by 32. Understood? This is how we are going to solve it. See here, students, once again I am repeating. In the case of combinations, observe this one carefully. 4 heads and 2 tails means what we have done means there 64 into we will worry about these 2 tails and we will write. But in case of this probability, no need to worry about the tails. Why? Because the total outcomes are 6 only overall. In that we will have 6 heads and 6 tails. There what we will do, please try to understand the difference between this one and there. If there are 6 men and 6 women, there we will have 6 men and 6 women. In that I need to pick, for example, 4 men and 2 women means there what we used to do 6C4 into 6C2. Why? Because from 6 women I need to pick 2 women and from here. But this context is different and this context is different. Overall the coins are how many here for me? 6. In that there will be chance for 6 heads or 6 tails. Understood? But our requirement is heads. That is the reason I am only checking about the heads. I am not even bothering about the tails. This context is different and this context is different. Try to understand the difference between these two. Most of the students will get confused here only. Please be careful. This context is different and this context is different. Understood? Right? Next one. On tossing 7 coins together, what is the probability of getting at most 2 heads? At most 2 heads, right? That means what are the outputs I want here? Tell me. What will be the possible outputs for me? At most 2 heads means 0 heads or 1 head or 2 head. Why? Because at most I want only 2 heads. At most I want. So no head, 1 head and 2 head. So from maximum to minimum. So no heads. So total, first of all, tell me what is the total outcomes for us here? 2 to the power of 7 which is equal to 128. 2 to the power of 7 which is equal to 128. Okay. Now 0 heads, that means 7C0 or 1 head 7C1 plus 2 heads 7C2. This is the desired one. 7C0 is what, students? 1. 7C1 is 7 plus 7C2, 7 into 6 by 1 into 2. 2 1s, 2 3s. So what happens to this? 1 plus 7 plus 21. This will become 29. So here the probability will become what, students? 29 by 128. 29 by 129. We cannot further cancel it. Reason is 29 is a prime number. So your answer becomes 29 by 128. 29 by 128. Okay. Now please see here, students. There will be some cases where we will see. For example, take the last example only. 7 coins are tossed. What is the probability of at most 5 tails? At most 5 tails. Okay, if that is the case, at most 5 tails. Now please see here, students, at most 5 tails, right? So, sir, at most 5 tails, so I will take 0 tail or 1 tail or 2 tail or 3 tail or 4 tail or 5 tail. Why? Because at most 5 tails are. Is this correct way to go solve this type of questions? Yes, there is no wrong in that by solving in this manner. But it will take a lot of time. Instead of that, in the beginning itself we have learned one thing, that is negation. We will take the help of that and we will solve it. How means, see here, total chances 0 tail, 1 tail, 2 tail, 3 tail, 4 tail, 5 tail, right? And similarly we will have 6 tail and 7 tail also, right? So that means total, that means what I will do is, at most 5 tail means, can I write in this manner, total minus, okay, total minus, or else 1 minus. Directly we can write 1 minus. Total here in the sense 1. 1 minus probability of 6 tails and 7 tails. Probability to get 6 tails and 7 tails. Yes sir. Anyway, both the answers are same. Either you find probability of getting at most 5 tails or probability of 1 minus probability of 6 tails and 7 tails, both will give us the same output. Now, to get 6 tails and 7 tails, what is the probability, students? I mean desired outputs in this case. Now I will solve this one by using this one. Desired is what for me in this case? 6 tails and 7 tails. That means 7C6 plus 7C7. 7C6 plus 7C7. 7C6, what it becomes? 7C1, which will become 7. And 7C7. 7C7 means what, students? 1. 7C7 is nothing but 1. So, here my desired is what? 8. What is the desired? This one. So, probability of this getting 6 and 7 will become what? 6 tails and 7 tails is equal to 8 by, what is the total number of probability when 7 coins are tossed? 128. 8 by 128. Yes sir, 8 by 128. Now, therefore, probability to get at most 5 tails. At most 5 tails is equal to 1 minus this probability, 8 by 128. So, now what happens to this, students? 120 by 128. 120 by 128. 8 15s are, 8 16s are. So, my probability here will become what? 15 by 16. 15 by 16. This is how you need to find the probability for the maximum cases. Now, if not, if you keep on adding all these things also, you will get the same answer, students. But it will waste a lot of time. So, sometimes we need to find the things in reverse manner. Not only always in a straight line manner, sometimes we will go in a negation manner also. Okay? Right? That's it, students. These are the questions based on the coins. In the next video, we will discuss the questions based on dice. How we are going to solve the questions based on dice and how they will ask us and what are the things they will ask us in the dice. We will see all these things in our next video. Thank you very much.